Back at it. Woo! This marshmallow
You have
wow.
a sequence of terms, yes? This is a sequence of terms. Those terms stand for partial sums. They stand for the sum. If I take the sum at infinity, that's what this stands for. This is the
That
sum
comrade
at
knows what a
infinity.
Geico counter looks like.
Well, if that converges, it means it goes to a specific number. That would be our sum of our series.
So we're back into the set here. I just got done with the field theory. We're talking about the walkthrough and the command directive. So the command directive of Calculus 2 lecture has some geometry, and they have to be congruent. They have to be. So the environment in itself is the circle. The arrow at 12 being the hour, the larger number, and, well, without the clock scale, you're not going to know x, y's on the value of this zeta function on either z top or z prime for the elevator. And that way you wouldn't know what floor you're on, and therefore how that's lensing inside of an environment. Just looking at this through a microscope, if you will, this particle through Feynman's 3 slits, over here is going to have some initial spin. And those things really make a difference of why they're orientated. Two things with the same orientation, but something moving in this direction, something moving in this direction, and two things chasing each other at two different values. This. Well, these are very clean. Well.
Sometimes you'll get the just diverges, the limit does not exist, therefore you can't do it.
Very clean. One arrow, two arrows at axis, two axis arrows with a zeta function, and an arbitrary set of both of those being augmented in the system. When you do this and this, that's what they do. There's a whole bunch on Penrose's twistor theory I suggest you read later.
It goes to my series. Therefore, if my sequence of partial sums...
Now I could write whatever I wanted in there, and that's what it would be. And they would be congruent with each other, or they conserved with each other. A is B. I just generally, like I said, will provide you with a map. This is a psychological map, actually. This is the difference of the pawn. Let's see if
I get there, that is my sum of my series.
Well, when he's talking about when you get there, first thing I see you doing is banging right into that corner from the 3 directions I first commonly know what you do when you walk into the store.
Still
Math.
YouTube for math help? Or the videos from 2006?
Oh, I ain't got time. I'm trying to condense this in a hurry because you want to be a master mason or a master's degree in mathematics tomorrow. So I will provide you with the friction you need, and you will do better than me. But until you can, me and the dean got that special handshake, you know. Shocker.
Something very simple. Here's the idea of what you're supposed
Like
to
I like
do.
Leonard's work. I'm just watching him, glassing him from the side. Yeah.
I wish I could have left this on the board.
Well, here's a map. You know, it's just a digital map. You know, what could I say is M1 and M2 inside of here? Where is M2 inside here? Yeah, M1 is the skid steer. They're congruent with each other. I have an operation as ground guy buttons I'm supposed to push, just and levers I'm supposed to do, just like the skid steer guy. And in this way, they are relative and necessary for one another because when I take one of them out of solution, given the sigma, it is deep. You're talking about big school management trades on there for watching guys, and just, I'm not going to work the rock. I'm not going to be on the equipment. I have to Mickey them so they get the best raise possible in the shortest amount of time, because otherwise they're going to hit me with some turnover rate shit that starts turning this into the system. Well, what difference does it make if I make this at the door outside of a training phase, in an arbitrary training phase that doesn't even fucking exist to most of these companies unless you're over at Lockheed Martin?
Do you understand that I'm stopping?
Plenty out there for you.
From 1 to n, where I stop. This is our partial sum here. So
there are other types.
Start at 1,
Let's call sigma sum.
Now, step number
Go ahead,
2.
give me some terms.
This is where it gets difficult. This is typically pretty easy. You just plug in some numbers, you go...
That's where I worked. I'll take you to the video, actually, what it looked like from this CT paradox.
Step number 2 is, you gotta find a formula for this. That's the hard part.
Well, I don't... To you, as another Mason on the board, I don't need it to be CT paradox. I'm going to be Larry's method. He's picking rock with a bay set up like this. you're going to go ahead and do it like that, because this is actually a multi-matrix of that combination. This is me at the master's phase where I have everything around me. I'm here. This is a pile of rock. I'm digging through it to the back wall. And I need to do that in squares. I need to do that in areas where it's sensible to say every about 2 hours I'm creeping forward, because it's no longer effective. Physically, I'm losing a second every single time. And if I lose a second on every single rock that I picked by hand,
it says that, hey, you want your 10th term in sequence?
but you would sit there in the environment and watch people do it. These are pretty comprehensive funny car numbers of ripping it down the track. And bosses want you to do it. Not only do the bosses want you to do it, the regulators want you to do it in the sigma sum, because it's congruent with their numbers for timelines on safety systems, turnover rates, or a different mechanic that's not necessarily quantifiable. See, I as a ground guy on saws and things like that, we used to change sensors, have to get in the brake, do screw bolts, manage the things, and that would have been fine during the day. But we had a maxed out operation over someplace like Delaware Basin Stone where
Now he's dumb, right? Because he's dead.
Bernoulli,
Do no more math.
Bernoulli's way up there, man.
Whatever he said.
But back to the stone, those stones were maxed out, plus the labor to output it, because hours were necessary to the day, where time or space and time correlate to Z at this. Space and time of the rock in the saw to how long it takes to cut it correlate to the numbers of workers you have, plus the numbers of workers with a pay, and that's over 2 different indexes of how that stone was picked out of that rock right there, right? Remember how, I don't know if I said it in this video, but remember how I said if you do it on this house, between your house and my house, all the costs are different. That's the first type of it that you're going to be really aware of. Now let's say me and you, we know each other's house. Let's say we have the same house. How you went through the system and I went through the system just on arbitrary systems, even though the answer still correlates to the same numbers, enough to destabilize somebody from it. Do the heating bill first before you do the telephone. And we have the same costs. We just did it as an experiment. That's how rigorous science is.
So basically,
it's going to require you to things popping through the universe to change your time and space line.
If I said, hey, find the partial sum for the first 6 terms. You should have to plug in 6.
Oh, yeah.
It'd be 6 times 7 over 2. Done. You guys with me on that one? Well, that's awesome. Now it says, find out what happens as n goes to infinity.
Well,
So our step number 3.
a few from the Bible, 217, 316. You can bust out the crayon on a Marine, you all of a sudden got SN plus N. The fun things I like to do to just dust off the reality of it. But remember how we didn't do it? Right there? These are field theory is nasty, man. Like I'm saying, taking Marshmallow out for a walk.
This is why I asked you this very first question.
Give him hell, Leonard.
I said, all right,